Hello, Jaguar students. It's your friendly neighborhood math teacher, Mr. Allred. And I know I told you that Unit 9 was over and done with, but guess what? I lied to you. That's right. I really did just straight up lie to your face. I know I've told you a couple times that I'm a compulsive liar, and that's very true. I'd like to talk to you about composite figures and complex shapes, okay? The really good news about this is that I've moved the test that was supposed to be tomorrow to Monday. A couple reasons for that is because tomorrow we have short classes because of the award ceremony, and I just think it'll make more sense to take the test on Monday. So we're going to take our Unit 9 test on Monday of next week. This is the last mini lesson in the unit. Complex shapes that look just like this one, okay? What we're going to do is we're going to go ahead and start with the notes, okay? You're going to see some pretty scary figures today. I'm going to work through about 3 of them with you. And what we're going to do is we're going to work through them together, and I'm going to give you 3 steps right now that will help you solve them. The first thing I think you should do is identify the 3D shapes that you see. Figure out if you're looking at a prism or a pyramid. If it's a trapezoidal prism or a triangular prism or a square pyramid, it'll be important to identify the shapes that you see. Then I think it makes sense to find the volumes of those shapes using the formulas that we've talked about already in this class, okay? And finally, I think it makes sense to add up those volumes of those shapes. I think that makes a lot of sense, okay? When you look at this first shape, I see 2 rectangular prisms. I'm going to show you why, okay? When I look right here, I can actually split this prism up with a little line. I'm going to draw a line from one side of it to the other side of it. And then I'm going to draw one line from here to here. And you should be able to see with that line drawn that I really have a big rectangular prism right here, a longer one on the bottom, and then a smaller one on top of it, on the top left side of it, up there. That's what I'm looking at, those 2 rectangular prisms. To find the volume of a prism, we take the big base times the height, and that big B stands for Ed Puzzle, ask him. That's right, it stands for the area of the base. So if we want to find the area of the base of this rectangular prism, we're going to do 80 times 10, because the base of this rectangular prism is this rectangle right here, this sucker. We do 80 times 10 times the height of it is 20. It's 20 millimeters tall. Mr. Allred, I don't see a 20 on there. That's because what I did is I figured out that this whole distance from bottom to top was 60 millimeters. And this part over here on the right side of this top prism told me that it was 40 millimeters from here to here. I used common sense and subtraction and figured out this missing distance right here was 20 millimeters. So I did 80 times 10 times 20. I got 16,000 millimeters cubed for the volume of the bottom rectangular prism. In order to find the volume of the the top rectangular prism, I did 20 times 40 times 10. But Mr. Allred, where did 20 millimeters come from? I know. It came right here. I knew that this whole distance across the bottom was 80 millimeters, but I also knew that this whole distance from here to here was 60 millimeters because the problem told me so. So again, use some common sense and some subtraction and figure out this front distance right here on the front of that prism is 20 millimeters, 10 meters across the width, 40 millimeters tall. When I did 20 times 40 times 10, I got 8,000 millimeters cubed. What do you think I should do next? The truth is, I'm going to add up those volumes next. I'm going to take 16,000 and add 8,000 to it, and I'm going to end up with 24,000 millimeters cubed of total volume of those rectangular prisms. Yeah, look upon that. It's pretty lovely. Okay, take a second to take a peek at that. There's some pretty good math up there. Okay, on this second shape, what do you see? I see a rectangular prism and a square pyramid. I'm going to find the volume of that rectangular prism on the bottom by using the same formula that I used before. Volume equals big B times H, where big B means area of the base. The base is a square, a 4x4 square. I can try to draw it for you real quick. Kind of looks kind of like this. I'm really bad at drawing these. With an line right here, there's your 4x4 square on the bottom, and it's 5 inches tall. 4 times 4 times 5 is 80 inches cubed for the volume of that rectangular prism. The pyramid on the top has a formula, big B times height divided by 3. And it's also a square pyramid, just like that's a square prism. Its square is just like this square that's on the back that I poorly drew there for you with those black lines. To find its volume, we're going to do 4 times 4, the area of the base, times 6. 4 times 4 is 16, times 6 is 96, divided by 3 is 32 cubic inches. So, to find the total volume of that composite shape, I can do 80 plus 32 and get 112 inches cubed for the total volume of that composite figure. I'm going to do one more problem here for you. I'm going to find the volume of this rectangular prism and trapezoidal prism for you. Okay? If you look up here, the formula for the area of a prism, of a trapezoid, is B1 plus B2 divided by 2 times height. I'm going to apply that formula to this trapezoid right here to find the area of the base of the top and do 5 plus 2 and get 7. 7 divided by 2 is 3.5 times 2 is 7. I'm going to take that area of the base, and to find the volume of that top rectangular trapezoidal prism, I'm going to multiply it by 10 centimeters. That's the distance from base to base. Okay, that's going to help me find the volume of the trapezoidal prism, 70 cubic centimeters. For the rectangular prism, on the bottom, I know the area of its base is this 3 by 5 rectangle, and it is a 10 centimeter height prism from base to base. So I'm going to take 15 and multiply it by 10. That gives me 150 cubic centimeters. That's right. If I take 70 and add it to 150, that'll find the total composite volume of those two three-dimensional shapes standing on top of each other. And you get 220 cubic centimeters as a nice, lovely final answer there for you. Okay, I've done 3 problems here for you. Please look at them. Please re-look at them. Okay, and lastly, but certainly not leastly, I want Edpuzzle to ask you what 2 shapes you see here. Okay, and it's going to ask you if you have any questions. Please keep in mind that in second period, I'm not in the room. Look around. You might have not noticed that I'm not in the room. You can always email me if you have any questions. I'm also going to be checking Edpuzzle throughout the day, so if you ask a question at the end, maybe I can answer it. Okay, 5th and 6th period, you are lucky enough to see me today. I'll be there in the afternoon, and I thank you for your time. Okay, please keep all hands and feet inside the ride at all times, and please wait until the ride comes to a complete stop to exit it. Okay, I would hate for you to jump out of the ride too early and end up hurting yourself because you didn't follow those easy directions. Remember to stay classy, and that of all the students I've ever taught, you are one of them. Have a great day. Thank you.